Hello, this is Nitin Dahad with the Times. I'm talking now to Soumyan Rajagopalan, who's the founder and CEO of Thalia Design Automation. Soumyan, hello.
Hello, good to be here.
So, Soumyan, Thalia Design Automation, you made an announcement this week. Just tell us what that announcement is, and then maybe we'll just dig into a little bit about what the company background is and what you're addressing.
There are two big features that we are introducing that we have introduced in the latest avatar of Amalia, which is our IP reuse platform. So one of them is Layout Automation Suite. This is a groundbreaking, unique capability that we are introducing specifically to address chip reuse segment. We've incorporated new features like automated device stretching, metal stacking, and being able to address electromigration requirements. This should reduce the amount of time it takes to migrate a layout from one process node to another by about 30-40%, in some cases even more. Along with it, we are also introducing a new feature to address FDSOI technology, specifically to identify and address the uniqueness in flip well devices. So these two are the two main features, and with this we complete the suite within Amalia, an end-to-end solution.
Okay, one key word you missed out in that introduction was it's analog IP design migration. Is that right? Because you didn't talk about analog IP.
Absolutely. Digital has had a lot of automation over the last 30-40 years. Yeah. Unfortunately, analog hasn't. And Thalia specializes in addressing this specific market, analog and mixed signal chip design reuse market. So we bring about automation in every aspect of the design flow where automation matters and makes sense, and in spaces where analog design expertise makes sense, we complement the designers and layout designers.
Now, I think one of the things I've understood, and maybe it's worth you just talking about the history of your product to actually understand where it sits now and how it differentiates, because I don't think we get from that exactly how this is different. And I think one of the key things is you're maintaining a lot of the intelligence in a previous IP block, and then when you want to migrate it to 28 nanometers or whatever, you're maintaining a lot of the intelligence, but then you're adding new bits which you're using as part of your tool, which has got the AI for all those process translations or migrations.
Right. So if you look at IP or chip reuse space, one of the uniqueness about this requirement is that the need to maintain existing topology, floor plan, or placement, however we call it, as we move from one process node technology or a node to another, right? The moment you start making too many changes, you start entering the realm of a new design, and that brings about new risks and other things, right? So what we do is, with the Amalia flow, all the way from the start until layout, is to preserve any intelligence that might have been imparted into the silicon, whether it is the schematics or the layout or any topology used for the circuitry. So we start off with the technology analysis capability within the Amalia suite.
And that was the first bit you introduced a few years ago.
Correct. So what this capability does is technology analyzer. Say you have your design in a 28 nanometer technology. If you plan to move to 22, a different foundry, the first thing you need to understand is how comparable the process technologies or the nodes are, and hence the impact on the design process, the duration, and the effort that would go into it. This automated capability that's on the back of ML methodologies is a fully automated flow, and with a click of a button, the software analyzes your source and target technology and provides a report and delivers a mapping file. It essentially looks at the devices that you use in your existing chip,
yeah,
in the source technology and provides a list of devices that you could use in a target technology. With this, you are able to make a good decision on if you are dealing with the right technology or not as your target. So with the mapping file, which is essentially a lookup table which tells you the devices, the most comparable of devices, the next software in this suite, the Amalia suite, is a circuit porting capability suite. And the first part of it essentially does the automated migration of schematics and test benches using this mapping table.
Yes. Yeah.
So a matter of seconds, bear in mind all of this is automated. In a matter of seconds, you have a schematic and a test bench in the technology that you want your design to be in, right? The next step obviously is verifying this design, which is again an extension of circuit porting capability, automated, click of a button, the software generates a report comparing the performance of your design in target against the performance in the source technology. And the next feature is the ability where we can add parasitics into your schematics. This is again another game changer which we introduced back in Q4 calendar of last year. 2024.
Okay.
Where we introduced the ability to have parasitics incorporated into your migrated design. So you now are in a position where the designer would be able to understand the potential impact of the migration, factoring in some level of parasitics. Now the parasitics, they come from the source layout. This capability also informs the user about the potential devices that they could tweak in order for the circuit to meet the requirement. And everything that I've talked so far is fully automated, which means other than the machine time and maybe a resource or two, you are not deploying any human beings there. And the last one in that flow is the layout automation suite,
which is what you've introduced now.
Right, which is what I talked about earlier.
Okay, now you've done what a lot of people say end to end, and sometimes I sort of question that, thinking, so what do you mean by end to end? Different, yeah. But you've actually done that quite well in terms of describing that whole flow. You've been doing this. You're one of these people who seems to have been at it for years and years. You started off at Micrel, and then you've evolved this capability, and you've been doing this. You founded the company in 2011, survived on research grants and innovation grants. When did this actually become something that you thought would be a good business?
2014 was when we were venture funded. So until then, we were looking at the AI algorithms that were out there and its viability in this unique problem statement, which is analog and mixed signal. So what we came out of the initial bit of the research and development was that Thalia needing to develop its own bespoke algorithms and AI algorithms, and what we now have in our repertoire is anywhere between 8 to 10 AI algorithms specifically targeting this analog design flow, along with ML methodologies that have been factored in. So the expansion of the Amalia suite happened around 2016 thereabouts, with the new customers being interested in the Amalia capability. So we expanded from having an optimizer to having circuit porting capability, which a lot of customers in Europe preferred, liked. And progressively the suite was expanded to include the technology analyzer and now the layout automation capability. The interesting thing here is that almost all the capabilities were developed on the back of what we learned by working with our customers, right? So all the customers that we have interacted with are a number of tier ones and fabulous and IP design companies in Europe.
And just to say, I mean, you're not allowed to say, but I think they're in the top 10 semiconductor manufacturers in the world.
Yes, yes, indeed. Some of them are on our website, and the feedback we received from them enabled us to build a capability and deploy it in the marketplace that was well aligned with what the market required. Given its analog, the uniqueness about the problem statement means that there has to be a unique solution as well, and that is what we were able to develop and demonstrate in the marketplace.
So I think since 2016 you've been generating revenue. So and I think you've raised a total over the last few years £5.5 million, which is about $8-9 million. So Soumya, what are the big sort of visionary goals you have over the next year, 2 years? What are your investors looking for you to achieve?
So one of the things that we've successfully demonstrated is, along with commercial traction, is the ability to build, develop, and engage with the customers with a broad end-to-end solution addressing all aspects of an analog and a mixed signal design flow. My goal as the CEO of Thalia Design Automation is to get the Amalia solution become the benchmark when it comes to anything related to analog and mixed signal design migration. So there are very capable solutions out there, but we are getting there. I want us to be the reference for for all these migration process, and I want to help as many customers, as many companies as possible in successfully getting their chips and IPs migrated to other technologies and nodes, and in the process expand their market opportunities.
Well, Soumya, thank you very much.
Thank you.